Hello students. Now today we will discuss about aldol condensation. Very important reaction, especially represented by carbonyl groups. Carbonyl compounds represents these aldol condensations. And what are carbonyl groups? Carbonyl groups are aldehyde and ketones. Aldehyde and ketones. So aldol condensation is given by aldehyde and ketones, in which these in presence of alkali undergoes condensation and gives bifunctional group bifunctional group compound. Bifunctional group means two functional group in one compound, and since aldehyde gives aldehyde plus alcohol, that's why generally these are called aldol condensation, because aldehyde undergo condensation in presence of alkali and gives bifunctional group compound that contains aldehyde and alcohol all. That's why called aldol. Since reaction is condensation, that's why it's called aldol condensation. So definition will be: aldol condensation is characteristic reactions of carbonyls, aldehyde and ketones in presence of alkali undergo condensation and gives bifunctional group containing compound and called aldol. But condition is only certain aldehyde and ketones, not all. Those that contains those aldehyde and ketones that contain at least one alpha hydrogen. Prior to it, in previous segment, in halo form we have discussed that 3 alpha hydrogen, but for aldol condensation just 1 alpha hydrogen. What is alpha hydrogen? The hydrogen attached with the carbon, directly attached with the functional group, is called alpha carbon, and hydrogen attached with this carbon is called alpha hydrogen. So the compounds, carbonyl compounds that contains at least one alpha hydrogen undergoes aldol condensation. Now reaction is like CH3CHO, acetaldehyde with two molecules of acetaldehyde, CH3CHO. The functional group of one carbonyl, that is this CHO. Now this is alpha carbon because this is functional group. So if we can note it like this, CH3 CHO in presence of alkali. Delocalization these pi electrons to oxygen due to more electronegativity. Here negative, it becomes positive. This alpha hydrogen shifted here forms OH, and here single bond is formed between these two carbons. So final product formed will be CH3CH, single bond OH, single bond CH2CHO. Two molecules of aldehyde contains 3 alpha hydrogen, but in aldol condensation we need just 1 alpha hydrogen. So functional group of one aldehyde with alpha hydrogen of another forms a product. Since here alcohol all and aldehyde both are present, that's why it's called aldol condensation. The product formed when heated it releases water. Elimination of water takes place. Here OH, here CH2. So along with OH in elimination dehydration, as per Sergeff rule, the hydrogen will eliminate from the adjacent carbon where the number of hydrogen is least. So elimination of water from here, formation of CH3 CH double bond CH CHO. When a product of aldol condensation or heat strongly gives alpha, beta, unsaturated aldehyde or ketones. Since functional group is attached here, so first carbon will be alpha, second will be beta. Unsaturation is at alpha and beta, so it's called alpha, beta, unsaturated aldehyde. Aldehyde. So in aldol condensation, when the product formed aldol is heated, elimination of water takes place and it gives alpha beta unsaturated aldehyde. If we take a ketone in place of aldehyde like acetone, CH3CO, CH3, acetone with next molecule of acetone CH3CO, CH3. Here delocalization of electron to this oxygen. Now CH3 can be noted in this way. We can note down it, hydrogen comes to this oxygen. Now product in presence of alkali in the same pattern, the CH3 single bond C single bond OH. Single bond CH3 here, CH3 single bond CH2 CO CH3. CH3 COH, CH3 single bond CH2 CO CH3. This when heated OH and H, elimination of water, formation of CH3 C single bond CH3 double bond CH because hydrogen eliminated from here. Now CO CH3. This is the functional group of carbonyl ketone. So this is alpha, this is beta. Again alpha beta unsaturated ketone is obtained. Prior to it alpha beta unsaturated aldehyde was obtained and here alpha beta unsaturated ketone is obtained. So in aldol condensation at least presence of one alpha hydrogen is must. So C6H5CHO, HCHO, CCl3CHO, CH3 whole thrice CCHO. These will never undergo aldol condensation itself. ये aldol condensation में पार्टिसिपेट नहीं करेंगे बिकॉज यहाँ पर कोई भी अल्फा हाइड्रोजन नहीं है. दैट्स वाई ये इटसेल्फ aldol condensation में पार्टिसिपेट नहीं करेंगे. बट सिंस दीज ऑल हैव carbonyl groups and in aldol condensation carbonyl of one molecule and alpha hydrogen of another is utilized. So since they have one carbonyl group, so whenever comes in contact with those aldehyde or ketones that contains at least one alpha hydrogen results aldol condensation. Like the last example here, C6H5CHO written in this way reacts with CH3CHO. Here alpha hydrogen is present. We can note in this way. Now carbonyl group of these, alpha hydrogen of these. In the same pattern, movement of atoms and movement of electrons, formation of C6H5 single bond C single bond OH. This is CH, single bond CH2 CHO. Again aldol is formed. So those aldehyde and ketones that doesn't contain alpha hydrogen will not participate in aldol condensation itself, but whenever comes in contact with those aldehyde or ketones that has at least one alpha hydrogen will undergo aldol condensation and give the product. This is all about for aldol condensation. Thank you.